Are you following any of these processes? If you answered yes to any of these, then measuring organics should be an important piece of that process. TOC Overview Part 1: Measuring Organics in Drinking Water. Why is it important? Organic matter is present to varying degrees in all water systems. Organic matter is defined as matter composed of organic or carbon-containing compounds that came from the remains of organisms, such as plants and animals, as well as their waste products in the environment. If we are made of organic matter and it is present in all living things, why should we care about organics in our drinking water? Organic material in drinking water affects the color of water. Which glass would you rather drink out of? Organic material can affect the taste and odor of drinking water. Some types of organic materials can contaminate water supplies. There are many terms used to define organics. Total organic carbon, TOC, is a measure of the carbon content of dissolved and undissolved organic matter present in a water sample. It does not identify the organic substance. Total inorganic carbon, TIC, is the sum of elemental carbon from carbon dioxide gas dissolved in water and dissolved carbonates in the water. Dissolved organic carbon, DOC, is the sum of organically bound carbon originating from compounds which pass a membrane filter pore size of 0.45 microns. Total carbon, TC, is the total carbon from all sources, organic and inorganic. Organic compounds, such as humic substances and aromatic compounds found in surface water, absorb UV radiation at approximately 254 nanometers. This is because most of these compounds contain conjugated double bonds in their chemical structure. There is a reproducible correlation between DOC and UV in both standard and process samples, as shown in this graph. Waters with low UV absorption values typically contain primarily non-humic organic matter and are not amenable to enhanced coagulation. Inversely, waters with high UV absorption values are typically amenable to enhanced coagulation. UV absorption measurements can be taken in several stages of the water treatment process to measure the removal of organics, such as after flocculation, after filtration, and after oxidation. Total organic carbon is a non-specific test, which means TOC will not determine which particular compounds are present. Instead, TOC measurements provide the sum of all organic carbon compounds. It is a direct measurement method, meaning it measures carbon concentrations. As this graphic shows, each parameter measures a certain part of the entire organic load. However, TOC includes more of carbon-based substances than just COD or BOD. Several methods exist for measuring TOC. However, each of the methods have these two common objectives. First, oxidize organic carbon to carbon dioxide, and second, measure the carbon dioxide generated. Knowing which parameter to use can vary depending on application, source water type, and regulations. UV absorption is useful for trending data, in optimization of processes, and for measuring naturally occurring organic matter present in surface waters. TOC measurements fully oxidize carbon in a sample, therefore capturing all compounds containing carbon, not just those with a double bond, allowing even more accurate disinfection dosing and process controls. Detecting, minimizing, and removing organics is critical for maintaining a high standard of drinking water. To ensure the minimizing and removal processes in drinking water are more efficient, effective, and safer, the organics should be measured in raw and finished water. Measuring the organics in your drinking water system will allow you to optimize your source water strategies, oxidation processes, coagulation processes, and provide you with the essential data to maintain high drinking water standards in your communities. To measure is to know. If you cannot measure it, you cannot improve it.